All right, so starting off the entire algorithms class, we are going to learn first about what's called the big O. You're going to hear this a lot throughout our entire course because this is how we measure how, it's not exactly how long, but this is how we measure the time or space complexity of a problem. So based on the input, relative to the input given, how long a problem is going to take. And so I'm going to ask you to calculate big O on every function that you create after this class. So let's go into a little bit more into the definition. So the big O means time or space complexity. We are going to pretty much focus on time complexity because that is what, when people are asking you the big O of something, they really mean the time complexity. Because thinking about the amount of space something is going to take has become a little bit less important as we have gotten way higher computer memory. It's a little bit less relevant, but sometimes it will come up in a problem, and we'll talk about that at the end when it does come up. But time complexity, we're not talking about the number of seconds your program takes to run. Okay? Time complexity does not mean literal time. It is all, there we go. It is the number of operations or steps that your function has to take relative to the size of your input. So I'll explain what that means a little bit. But just a side note, the big O means the upper bound. There's theta or big theta, there's other things which are the average, but big O means the upper bound of runtime. So this is the worst case scenario. So if you have a problem, your big O is your worst case scenario on how many steps would be taken. Okay, so to explain how this is the number of steps taken relative to the size of your input, let's talk about this little example here. If you wanted to send data to your friend across the country, what is the fastest way to send it? Option 1, through FTP is file transfer protocol, so sending something electronically, right? So I would upload my file to Google Drive, and then I'm sending them that file. Option 2, hand deliver. So which one do you think is the fastest way to send it? Okay, I hope you've got an idea. The answer is it depends. Okay, so if I'm sending a friend some files, if those files are small or medium size, it's going to be faster for me to send it electronically than for me to get on a plane and deliver, put it onto a USB and get on a plane and deliver these files to my friend, right? It's so much faster to just upload something. But if a file is really big, it's going to take many hours. It might even take a full day or two to upload this file and send it. And so for those files, it's actually faster to get on a plane. So the reason is, no matter how big your file is, if you're getting on a plane, it's going to take you 6 hours to get across the country, right? So if you have a small file, it's going to take you 6 hours to hand deliver that file. If you have a huge file, it's going to take you 6 hours to hand deliver that file. But if you have a small file, it'll take you 1 minute to electronically send it. If you have a huge file, it'll take you a day and a half to electronically send it. Right? For enormous files, it's actually even faster to drive the file across the country. Right? So what I'm trying to get at with that is that I hope you can see my mouse, that as file size increases, we're going to look here at the time to send. For physical delivery, this green line, as the file size increases, it doesn't matter. It stays at 6 hours in time to send, right? It's staying equal. It doesn't matter. But if we're sending it electronically, this red line, it starts here, it's going to take a few minutes, and it steadily, it's going up, and depending on file size, as the file size increases, your electronic delivery time increases as well. So that means that the big O of electronic delivery is, I made this line a little bit, it's probably about linear, right? Or maybe exponential, so curving up like this. But it's some sort of line that's not straight across, right? It's not constant time. It's not a constant 6 hours like the physical delivery. It's a more dynamic, maybe linear, maybe exponential slope of, as the file size increases, the time to send increases. So in this case, we would say that physical delivery is constant time, and electronic is not constant time. It's going to be some other big O. And so for big O, we're talking about the worst case scenario, right? We're talking about big O. The entire reason we're focusing on big O is because of scale. So for big O, we care about how are things going to look at scale. So even though this physical delivery, in all these small to medium cases here, it takes way more time to send a file, we care about the way up here, this huge file size part of the graph. And when the file size is really big, constant time wins out because this other one is continuing to grow upwards. So constant time is the best runtime you can have, because even if, you imagine you had a constant runtime of 10 minutes or something, right? That's lower down here. And a constant time of 6 hours is higher up, so maybe that's a worse constant time. But at really big scale, it doesn't matter. At really big scale, your constant time is always going to be the least expensive thing than a graph that's growing. So to say it again, this is showing how relative to your input, right? This is all relative to file size. We see that constant time is the best. And then linear or some other time is going to take longer. Okay, so this all depends on file size, right? We're not only looking at this small, like if file size is, 1 megabyte. So let's see some examples of how that looks in code. Oh, sorry, actually here we'll go to, here we were talking about the slopes and how those different things look. Here are the different slopes. So constant time, the way we write that with big O is O of 1, means constant time. And that is this black line down here. You can barely really see it, or maybe they're talking about this green one, but it's flat across, right? O of 1, it's constant time, it doesn't change. Our next best runtime is O of log n, because O of log n means that we are reducing. We'll go into what it actually means later on when I give you an example that will make more sense. But basically, O of log n is our next best case, right? That means that it's not linear. It's not increasing in a linear line. It's increasing between constant and linear. Then we have linear, which is O of n. So that means given an input of size n, I take n steps, worst case, to figure out this function. So if I'm going through an array, the array is of size n, and I'm doing a for loop to go through the array, I'm going in that for loop n times, right? It's an array of length n. I'm going through it n times. So that is going to be an O of n runtime. If I have an array and of size n, but I loop through something 5 times, no matter what the size of the array is, that's O of 1. Because I'm saying, oh, hey, no matter how big the array is relative to the input, I'm always just doing 5 steps through this array. So no matter what, it's going to be constant. Then comes O of n log n, which is n times log n. So for we'll go into what that means in more detail, but that's your next step between, remember log n is less than n, right? So you've got O of 1 constant, then log n, then n log n, and that is the midway between O of n squared. And then we get into some crazy runtime, which are 2 to the n and O of n factorial. But in general, O of n squared is probably, once you get into O of n squared, you probably want to make your function a little bit more efficient, right? So we're going to be looking for ways to optimize our function once we're in O of n squared runtime, because that gets to take a really long time at scale. O of n log n we're okay with, but we don't love. Okay. Oh, I see. So these black lines are the ones that represent the different stages of where we're at. So here, this is O of n, this whole section here. This section is O of n log n. Okay. So, O of n log n we're okay with. Really, we can't optimize, but we're hoping for things closer to O of n. And sometimes you get O of n squared, usually when you have a nested for loop, and you can't escape it, but it's not great for runtime. All right, so now let's talk about what those different ones mean. So O of 1 is constant runtime. So this means no matter the size of your input, you are just going through it, you are taking the same amount of steps. So things that take constant time is basic math, addition and subtraction, right? So if I'm multiplying 5 times 4 or variable a times variable c, that takes the same amount of time whether I have an array of size 10,000 or an array of size 2. Assigning variables, so var a gets 7, right? That is also constant. It doesn't matter how big my input is, it takes the same amount of time. If else conditions, when you declare functions, a function, my function, indexing into an array, so getting a specific element out of an array, is constant. And we'll go into that in a future class of how that exactly is constant, but when you get a specific number out of an array, it's constant. When you're doing a loop through an entire array, now it depends on how many elements are in the array. But if we're just getting out a specific element, it's constant. And changing variables, so var a gets 7, and now a gets 15. Same thing, it's just assigning. Okay, so that's constant. Now we go to O of log n, which is called logarithmic runtime. This is when you're splitting a data set in half on every iteration. So the best example of this one is a binary search tree, which is the data structure we'll go into. But basically, you're saying, oh, hey, I have a dictionary, and I want to find the word hippopotamus. I'm going to open the dictionary in the middle, which gets me to letter M, let's say. I know that H, I'm looking for hippopotamus, H is less than M. So I'm going to completely disregard the second half of the dictionary. It's sorted, right? So I don't need to search there. So now I go between, I've got my dictionary from A to M, and now I'm going to open it halfway again. And I get to G. And I say, okay, H is greater than G. I'm going to disregard A through G and just look on H through M. And I basically am just going, as you can see with this dictionary thing, I am removing half of my data set every time I'm searching. So that's an example of a logarithmic search. And when you have something that's log n, you're usually talking about sorted data, because that's how you're able to disregard half of it. So you don't need to memorize that right now. You'll see some examples when you're using log n, but just so you know, it's when your data set is being split in half in every iteration. And then we get to O of n. So after constant time, O of n is another one of the most common ones. So this is linear runtime. You should think automatically, your brain should go to, whenever you see a loop, you need to look closely, but usually a loop is O of n. And that's when you're going through every item in your data set. So your input, you're going to hit every item in your input. Okay, and remember, big O is the worst runtime. So, maybe you're hoping that you're going to like only go through half of your elements or something. But it's still, we would still call that the linear runtime. It's still going to be O of n. Then we get to quadratic, so O of n squared. This usually is when you have nested loops. So you have, for var I gets 0, and inside of that, for var j gets 0. Right? So you've got 2 loops. And that is O of n squared. And we'll go into why it's O of n squared pretty soon. But what that means is that for each item in a data set, you're going through every other item in that data set. So that's O of n squared. Okay, so here we go. Why do we care? Because this shows the scale. So we talked about this a little bit earlier. But for really big data sets, we're trying to know how long is this problem going to take? Right? So here, there's constant runtime, which is going to, maybe at certain points, it's way higher, right? If you're running through something 1,000, you loop through something 1,000 times. Well, for a really small array, 1,000 times is going to be longer than looping through every element in the array. For an array of size 5, looping, doing 1,000 operations is going to take longer than going through 5 elements in an array. But as that array grows, once it gets past 1,000 elements, now the constant time of 1,000 steps doesn't look so bad. So we care really big scale. And this also shows why we're not going to care about constants. So here, if you have O of 2n, so you say, oh, hey, I'm looping through this array 2 times, we're just going to call that O of n. We drop any constants that are before, like any numbers, unless it's a square, like an exponent. So like n squared we care about, but because that's n times n, right? It's not really a number. Any numbers that are here, so these are actually called coefficients, sorry. We're going to get rid of them because we just care about scale. We just care about the slope it's going to take in our graph. We don't really care about the number. So O of 2n, we're really just going to call it O of n. And here, if there's, let's say your function does 2 different things. It has a nested for loop and it has a regular loop next to it. So that's the regular for loop's O of n and the nested loop is n squared. We just care about the biggest one. So if you've got 2 elements here, we're going to take the largest to make our big O. So it's just O of n squared. Okay, here we go. Here's a quiz. So I know this is some pretty weird pseudocode. Actually, it's not even pseudocode. This is C. So apologies for the confusing syntax, but you can get the idea, right? So here, int just means let or var. It's similar to TypeScript. It's letting you know what type the variable is. So here, it's assigning a min and a max. These are both functions to get out the min and max of an array. And it says for element in the array, if that current element is less than what I have assigned as my min gets current element. If that current element is bigger than my max gets current element. And we've assigned them, min gets an arbitrary max value, something way too big, and min gets a min value of something super low and negative. Max gets that min value. Min gets the max value, so that they'll reassign here. And here is the same problem, but instead of in this for loop saying if x is less than min gets x. If x is greater than max gets x. It has a separate for loop for each of them. So I want you to take a second and think about the runtime. You can pause this recording here. So let's talk about the runtime for this one. Here we have a for loop. And then we're just doing an if statement. So if statements, remember, x less than min, it's just a comparison. These are all constant time. If x is less than min, constant time, comparison, variable assignment, constant time. So both lines 4 and 5 are constant. And it's inside of a for loop. A for loop is linear, O of n. So this whole function here, and here lines 1 and 2, they're each O of 1, constant time. So this full thing is O of n. Now, what do you think this one on the right is, now that you know that the one on the left is O of n? You can pause the recording here to take a guess. Okay. The one on the left is O of n. The one on the right is O of n plus O of n. Right? Because these for loops they're both here, which is O of 2n. So we drop constants. So O of n is equal to O of 2n. And I wanted to put this here just to show you why, one of the other reasons why we drop constants, because these are actually doing the exact same thing, right? These functions are the exact same thing. It's just that we just separated out into two different loops, but they're just running through the array and making these two comparisons. So yeah, we're going to drop constants, and we just care that both of these are O of n. Okay. Now, you saw on this past screen that this one on the right is O of n plus n. O of n plus O of n. So we want to know, when are we going to add and when are we going to multiply? Like, why wasn't this O of n times n? So we add the big O's in a function. We add them when it says do this, then do that, right? So here we did do this for loop, then do this for loop. You multiply when you say do this for each time you do that. So let's see what that means. Here, add. Usually we're talking about O of n, by the way, but you can, if your input is A instead of n, you can say O of A. You can, if you have multiple two kind of separate runtimes, you can use letters like that. So here we go. For array A, print A. For array B, print B. This is O of A plus O of B. But here, for array A, for array B, print A, B. So here, this is saying for every element in array A, go through every element in array B, print A, B. So you're saying for element 0 of array A, go through element 0 through B dot length of array B. For element 1 of array A, go through element 0 through length of array B, right? Which is super, so for every element in array A, you're going through every element in array B. Whereas on the left side, we're saying go through every element in array A once, go through every element in array B once. So that's why it's A plus B. But on the right side, we're saying for every element in array A, you're going through every element in array B. So you're going through array B the number of times you have elements in array A. So it's a lot more. Okay, you're not just going through array B once. So that's when you're going to multiply. And you're thinking about it mostly when you have nested loops. All right. So I'm going to go through a bunch of practice problems, and I want you to pause with each problem. I want you to pause this recording, and then you can play it when you have a guess, and we'll go over the answer. So here, let sum get 0. For let I get 0, I less than n, I plus plus, sum plus gets I. So here, we're going through the array n. This n should be n dot length. Sorry about that. And we are just adding up the number of, actually we're just adding up the length, I suppose. This is a weird problem. I had ChatGPT generate some things, and it has some issues. But anyway, what's the big O, forgetting the exact details of what we're doing in this function? What is the big O of this? You can pause here. This one is O of n. So we're going through, based on our input size n, we're going through every element in n, and we're doing a constant operation for it. So it's O of n. Let's go on to the next one. All right, here we go. We've got for every element in n, go through every element in n again and add and do a sum. So pause the video here and let me know what your guess is. Okay, this one is going to be O of n squared. Remember, nested for loops are usually O of n squared. Let's try this one. Because for this last one, it was for every element in n, we're going to go through every element in n again. Okay. I think I just put the exact same ones. This one is O of n squared. N times. Oh, oops. I think I must have copied the wrong one. Sorry about that. I think, oh no, I didn't. It's not the same. Okay. So in this last one, I said, while j is less than n, right? So we're going through every element in n. For here in this for loop, the outer one, I'm saying while I is less than n, so you're going through every element in n. While j gets 0, j less than I. So when I is equal to 0, it's not even hitting this loop. When I is equal to 1, it's going through once, right? So that's the interesting thing. I wish I hadn't shown you the answer. But feel free to, if you forgot what it was, feel free to pause the recording and try to figure this out. But basically, here, even though this inner loop is not the full size of n, when I is all the way at n, it will become n, right? So here, this inner loop is really O of n divided by 2, because it's only going through about half the elements. But we don't care about numbers, right? We get rid of the numbers because we care about scale. So it's O of n, this outer one, times this inner one, O of n divided by 2, which is equal to O of n times n, which is equal to O of n squared. So even though it doesn't exactly go through n elements, we still call it O of n squared. And now for this one. We've got a for loop while I is less than n, an inner loop there while j is less than n, and then an inner loop for while k is less than 10. So definitely pause the video here. There's a really interesting one. Pause the video and we'll discuss. Okay, so I'm going to give you a hint, and if you didn't get it last time, then I want you to pause the video and do this again. But this inner one, for let k get 0 while k is less than 10, k plus plus, that is a specific number of loops you're going through. So this inner loop is actually constant because it doesn't depend on the size of your input. It's just going through 10 steps. Okay? So pause the video and try again here if you didn't get that last time. Okay, so now we've got an outer loop, which is O of n, an inner loop, which is O of n, and an inner loop, which is O of 1 constant time. So it's actually going to be O of, oh no, I'm so sorry, I got this wrong. I'll fix that. But it's actually going to be O of n squared. Let me fix that right now. That one is going to be O of n squared. Okay, wonderful. Let's go on to some other practice. So here, I've got a quiz. I'm going to include this in the video description. So I want you to pause the video and go fill out this form. It's totally anonymous. It's just for the point of you being able to quiz yourself. So you'll go to this link. You'll go to this link here and fill out the quiz. So pause the video, fill out the quiz, and then come back here. Okay, and we'll go over, remember, you can take a screenshot of any questions that you have on this quiz. we're going to have our office hours class where we're all together. So you can ask any follow-ups on ones you didn't understand here. Okay, so now let's go through some extra challenges. These ones are going to be a little trickier than any of the other ones we've gone through. So again, you can pause the video after I go through each one, and then I will do the answer. So here we've got while I is less than the length of array A, and inside that a for loop for while j is less than array B length, console log array A of I and array B of j. So pause video here, take a second. So this one, the reason why I say it's just a little bit of a challenge is because if you put down O of n squared, you are absolutely correct. That would be super acceptable. You could also say, because your input in this case is represented by A and B, you could say that this, you could say that this is O of A times B instead of n times n. And it's slightly more accurate because you're just saying it depends on the length of input A and input B. Okay. Now let's go to this next one. So this was O of A times B. Now this next one. Here, same thing. We've got these same loops, but now the inner part is a loop of 1,000,000. We're going through 1,000,000 times, and we're console logging. A very boring function. Okay, so take a second, pause the video, and try to figure out what this one is. So this one is actually the same. So here, right, on the one above, we were just console logging, which is constant time, but it's inside nested loops, which is O of n squared, or O of A times B. And the second one is the exact same thing because the inner for loop doesn't depend on the length of either A or B. It's just going to go through 1,000,000 times. So even if array A has one element and array B has two elements, we're going through this 1,000,000 times. So that's constant. And this is still going to be O of A times B. And now here for reverse, a function called reverse. We're going through while I is less than the array.length divided by 2. So we're going through half the array. And we are going to, and we're doing some swaps. So we're saying, it's just, we're saying, okay, grab this element from this array and swap it with this element from this array. This is a really tricky one. So pause the video and give a guess. Okay, so in this one, this outer loop is O of n divided by 2, right? Because it's the array length, but divided by 2, it's O of n divided by 2. But if you remember, we don't actually care about the numbers before it because we're talking about at scale. So O of n divided by 2 is just O of n. So this outer one is O of n, and then on the inside, it can look different because we're saying array sub I and array sub other and these other things that look more complicated, but they're actually all constant time. We're just saying, hey, remember to access an array at a specific index is constant time. So array sub 4 gets array sub 7, and that is a constant. You're assigning a variable which is constant, and you're grabbing an element in a specific index in the array which is constant. So this whole thing is actually just O of n. All right, here's a little extra quiz. Which of the following are equivalent to O of n? So here we've got O of n plus p, where p is less than n divided by 2. We've got O of 2n. We've got O of n plus log n. And we have O of n plus m. So take a second, pause the video, and write down your best guess. Okay. So all of these are equivalent to O of n except, well, this last one you could say either way. You would probably want to say So let's start with the first 3 and explain why. In this one, O of n plus p is less than n, right? So we're always taking the biggest. When we're doing big O, we just take the biggest number. So here, p is less than n, so we actually don't care about it. It's O of n. The one below, O of 2n, we don't care about numbers, right? Unless they're exponents, so it's like n times n squared. We don't care about the numbers, the coefficients that come before, so we get rid of that. It's O of n. The next one, O of n plus log n. Log n is less than n. So again, we're taking the biggest one, and it's O of n. This last one is the only one that you could argue might not be O of n, because it depends how big m is here. So if m is bigger than n, this will be O of m. That's actually not a great way to say it. Basically, you could say that this is O of n because their slope is going to be the same. But sometimes you want to leave it as a little bit more accurate to say n plus m because it gives a better idea of the input. So the input is, this function is going to depend on the size of the input for n and m specifically. And you don't know which one is bigger, so it's just more accurate to leave it. But you can really say all of these are equivalent. Okay, that's it for time complexity. This is a super hard topic. We're going to be going over this way more. Now, as just an added bonus, I'm going to talk a little bit about space complexity, which is the other thing big O is used for. And it's the same concept. You're saying, given an input n, how much new space and memory will your program take up? So it's all relative to your input. So if you're creating new data structures whose size or quantity of variables depends on the size of your input, then this is not constant. New data structures usually are non-constant. So for example, if you have a problem where you take in an array and then you're creating a duplicate or a copy of that array, you're going to create n additional elements in memory. So that's O of n. So usually space complexity doesn't come up, and people aren't asking you about space complexity unless they say, hey, solve this problem with constant space complexity, which means they don't want you to create a copy of a data structure. They don't want you to create a copy of your array. You can create individual variables because that's constant, right? You can say var a gets array sub 0, but you can't say array a gets copy of array n. So that's usually, it comes up just with saying solve this with constant space complexity. Okay, and here are some additional resources that you can use if you're a little, you want some extra time with this topic. There's a good explanation video. This cheat sheet is similar to what I showed you before with that graph. It just tells you, which ones are ranking in terms of worse, and gives you a little bit more information, like, in order to access an element in an array, that's O of 1. To loop through an array is O of n. It just gives you that cheat sheet for different data structures. And that is it. So I hope you enjoyed. We'll talk about this in our office hours. And that's it. So definitely go through the quiz, go through everything, and see you soon.